Hello, everyone. Today we're going to cover Chapter 6 in the Enterprise Architecture and Cloud Computing textbook. Chapter 6, Why Cloud? Why Now? It begins with the discussion of the traditional approach. This was common in the 1970s, 80s, and 90s. There was an in-house design of a system, in-house development and deployment, which took months, if not years, to implement. There were very high implementation costs, including hardware, software, and licensing of those hardware and software. There were also the need for professional services and technical skill sets, which had to be maintained in-house. The management of the infrastructure required an extensive investment on the part of a company. So we compare that with today's cloud implementations, which offers a distinct competitive advantage to the companies. Infrastructure management is much easier. You can deploy fairly rapidly. You can implement application programming interfaces, APIs, or I believe in Chapter 2 and Week 2, we refer to those APIs as Enterprise Application Integration or middleware. That's a common term, middleware, which allows for easy integration of disparate systems. For example, from one vendor to another, vendors need to communicate through their systems. They can use middleware, or from legacy applications to new systems, you can use middleware, or from just various applications that don't communicate with each other, you can use middleware. So it gives you tremendous flexibility and, again, rapid deployment, rapid configuration, and you can use a pay-as-you-go pricing strategy. Just as we do with our telephone bills and our electricity bills, we pay for what we use. That is the strategy, the pricing strategy behind cloud computing, and so you only pay for what you use. It is easy to test multiple configurations. You can go with a prototype environment, and in the prototype you can test multiple different configurations and then decide which configuration works best for the company and deploy that configuration with ease. It allows the company to focus on product deployment and product development rather than on infrastructure management and infrastructure deployment. Cloud computing is a natural progression from the centralized mainframe environments to the distributed client-server architectures that we talked about in Week 2. The mainframe of the 70s, 80s, and early 90s introduced a single point of failure, and if the mainframe was down, nobody could do any business, and this could be a tremendous bottleneck. Of course, the birth of the PC in the mid-1980s, 1984 or so, and the development of the internet in the mid-1990s allowed for enterprise systems to connect to the rest of the world, and it enabled workload distribution through multiple nodes or multiple different locations where you could connect your services or your network through the internet. The gains in flexibility led to a decrease in effective governance. By that, we're talking about the lack of standardization. All of a sudden, you have a lot of different departments who are developing their own little internal systems. I think we talked about them early in the course. We called them information silos. The information silos have a lack of governance, so you don't have the standardization, you don't have the consistency, and it introduces security issues. It's like the wild, wild west in this chapter. It talks about a wild west effect where applications are rapidly deployed, but the trade-off is that there was no security or little security in place, which led to security breaches, cyber threats, and identity theft, Also, the stealing of intellectual property was an issue with these systems. So then the PC-enabled client-server era allowed the systems to be implemented faster, but integration and interoperability issues were very common. There was widespread patching. I remember the patching of the 90s Windows operating systems and all of the patches and service packs that needed to be deployed to a large organization could take a lot of man hours and a lot of labor. And of course, the missing patch could then introduce yet another security breach. We've seen that in several circumstances here recently. But this led to a new breed of infrastructure. And as a result of all of the issues with security, you have a new group of security professionals and operational professionals and infrastructure deployment professionals who focused on the security of these new PC-enabled client-server architectures. The maintenance of information silos detracted from doing business and/or product development. The internet, however, led to globalization and ubiquitous systems. Ubiquitous meaning anytime, any place. I believe in chapter 6 it talks about 24/7, 365. So you are up all the time and you can access from anywhere as long as you have internet access. The speed to market focus instead of the manageability and standardization focus was an issue, which led to increased industrial espionage. So then we move to cloud computing, which takes the best of the mainframe era, where you had a centralized, very large mainframe environment that was providing computing capability. The mainframe became the storage mechanism, or the database, if you will, in the cloud computing environment. You have the best of PC-enabled client-server era architectures, and you had the internet. So you combine the mainframe's capability and storage for database purposes with the PC capability and applications that can either reside on the client or on the server. If you're talking about a 3-tier architecture, which we talked about again in chapter 2 in week 2, and then you combine that with the internet, and now you have the ability to take advantage of the speed of your high-speed internet and the speed of the PC and the speed of a client-server environment and the storage of a mainframe, very large scalable storage made possible by integrating a mainframe. And you include the pay-as-you-go billing model. You don't have to purchase hardware. If you're a company, you don't have to purchase hardware. You simply purchase the service instead of purchasing a whole lot of software or developing software in-house. You simply purchase the service and pay as you go. No hardware required, no facilities or data centers have to be built, no large scale data centers like the ones I used to work in back in the day were needed, because those capabilities and facilities were provided by the cloud vendor. This is an example of, if you look at a diagram of cloud architectures or cloud computing, you will see these types of symbols: a physical server, maybe a virtual server. Virtual server simply being the ability to access a server that is housed somewhere else. The best example I can give you of a virtual server is when I taught Microsoft classes. I would go into the classroom with a virtual hard drive. The virtual hard drive was simply the configuration of the Windows operating system and all of the capabilities in the database, maybe if it was a SQL Server class, all of this, the configuration and all the software and the hardware configured on this virtual server, which I could then deploy to PCs in the classroom. So if there was a classroom of 20 students, I could deploy the virtual hard drive to the 20 students. We didn't have to have the physical capability. We could simply use the virtual server to conduct the class. It was a very quick and easy way to get a class up and running, and the students would then connect to the virtual server using something like Citrix or PC-enabled software that allowed for you to run the application, the software on the computer, the student computer, and then deploy the virtual hard drive. Then there's a software program. Usually the symbol for software program is in the middle, the blue rectangle, I guess. The service is the yellow ball. The storage device is the cylinder, and then the network device itself. So if we look at a cloud diagram, you see in this example, you have 3 virtual servers, and you have 2 services and 3 databases or storage devices. This is a typical example of a cloud architecture. So, the textbook says that cloud computing is to computing, traditional computing, I guess, as the iPhone is to telephones. The innovation of the cloud has taken computing to the next level, just as the innovation of the iPhone has taken telephones to the next level. It provides massive amounts of distributed computing resources, network access over the internet, on-demand software solutions using software as a service. You might recall that our Infor CSI that we've been using for the past few weeks was a software as a service platform. So we simply logged on to the web, connected to the Infor Cloud Suite, and were able to conduct transactions that were stored in a database, but we didn't have the software on our systems. All we needed was an internet browser. Then you have platforms for scalable solutions, platform as a service, or virtual data centers infrastructure as a service. So you have software as a service, platform as a service, infrastructure as a service. Examples, and in your textbook there are several case studies which I recommend that you take a look at. Instagram, they talk about the development of Instagram from 3 guys who basically deployed a solution, a cloud-based solution, Instagram, Netflix, which we all are familiar with, Google's Gmail. If you have a Gmail account, you are using a cloud solution. The Obama campaign itself ran on a cloud. So there were many common household businesses and or companies that we recognize that are that were deployed using the cloud. In summary, cloud computing is one of the biggest technological shifts since the birth of the PC and the adoption and introduction of the internet in the mid-1990s. 1995 was the first graphical browser. Before that, now the internet, keep in mind, the internet has been around since the 70s, but the commercial internet that we all know and love became possible as a result of a graphical browser that was made available through a company called Mosaic, which eventually became Netscape. And then in 1995, Internet Explorer came on the scene, and now we have Google, we have Google Chrome, we have Safari, we have Firefox, we have Internet Explorer, we have tons of capability through various browsers that are available to usually free of charge. In the case of Windows, Internet Explorer comes with the operating system. And so it's very easy with the internet and the browser to deploy a cloud solution. Software as a service, as I mentioned before, Enforce CSI that we've been using for the past several weeks was a software as a service deployment. Then there's also infrastructure as a service. Amazon Web Services is an example of the IaaS, or infrastructure as a service model. And I believe that Infor has deployed their software as a service using Amazon Web Services. Then you also have platform as a service, Google's app that we all use all the time. Very common implementations of the three models, the most common three models of cloud computing: software as a service, infrastructure as a service, platform as a service. There's also a hybrid solution which combines the infrastructure and the software as a hybrid solution. The cloud computing models: you have computing power, you have database storage, you have content delivery, you have network capability, all bundled and all deployed without the need of having in-house expertise. You simply hire a vendor, a cloud vendor such as Amazon Web Services, and you rely upon the vendor to deploy your services and configure your services for you and keep them running. It removes all of the headaches of maintaining a data center and maintaining a staff of employees. Of course, the trade-off is that you're giving up control. If you're the company, you're giving up control to a third-party vendor. But we will talk about next week, we'll talk about service level agreements, which have to be in place between the vendor and a company to outline exactly what is expected from both parties. So we'll talk about service level agreements, very important for cloud computing deployments. This has been our discussion of Chapter 6, Cloud Computing. Why cloud? Why now?